Bismillahirrahmanirrahim. Assalamu alaikum. Welcome to Technogenius. Today our topic of discussion is FACTS devices, and FACTS devices stand for flexible AC transmission systems. So if you see the name, it indicate that it is relevant to the AC transmission system. So these are the special devices which are used to enhance the facility of the AC transmission system. So initially, what we see is in the conventional power system there are many limitations and many problems which we face normally. As you know that there are two types of power which we are using in power system. One is active power and other one is the reactive power. So the active power is usually due to the resistance and the reactive power is usually due to the capacitance and the inductance. Now the problem is that the active power is actually the true power which we are using for the equipment and which we are transferring, but due to the reactive power the capability of the power system is reduced. So in order to maintain this reactive power we would use many devices to improve the capability of the power transmission. Now, the in conventional power system, due to the reactive power, there are many problems which occur, like the stability of the power transmission, or the thermal limitation of the power system, or the voltage fluctuation. Sometimes the voltage of the input of the transmission line is reduced as compared to the output of the transmission line, and sometimes the input of the transmission line is increased as compared to the output of so the important factor in transmission line is voltage regulation. So this voltage regulation is also disturbed in the conventional power system. So we cannot maintain the state of equilibrium. There are other problems which can occur in conventional power system, is like the fault. As you know that the common type of fault which occurs in the transmission line is line to line fault, line to neutral fault, or line to line to neutral fault. So these types of faults, when these occurs, it will increase the voltage level of the output of the transmission line. Similarly, there are many other faults which occur in the transmission line. Similarly, when there is a slight change in the load, or abrupt change in the load, due to the change in load, the distribution or the voltage drop is increased. And another problem which we face in the transmission line is when we increase the generation unit, or the capacity of the generation unit increase, the losses in the transmission line is increased, which disturb the overall efficiency of the transmission line. Similarly, when we are switching the transmission line, the overall efficiency or the output of the transmission line is disturbed. Another problem is that due to these losses or these interruption, sometime tripping may occur. So we need to improve the stability of these transmission line. So the traditional way to improve these stabilities are the fixed mechanical switches, which are with capacitors or reactors connected in series or parallel. So it will improve the capability of the system, but these systems are comparatively slow. Their response is very weak or slow. Similarly, they are mechanical switches, so their wear and tears are very high, and their maintenance are very costly. Similarly, they are relay based. The switching time of the relay is comparatively very large, and it produces the delays. So these fault may damage our load or our transmission or the generation side of the transmission. So in order to improve this thing, we use FACT devices. So FACT devices are the devices which are basically based on power electronic or the thyristor based devices, and it virtually produce the reactive power. So based on these FACT devices, we can smooth the response of the power transmission line. Similarly, the continuity of the continuity or the reliability of the power transmission is improved. Similarly, the compared to the traditional methodology, it has comparatively fast switching. So these switching gives advantage over the mechanical switching of the system. So the controllability of the system is increased. That's why it is called flexible devices. So by definition, if we see the definition of the transmission line, FACT devices, it is a power electronic based system and other static, it uses other static equipments which provide control of one or more AC transmission system parameter to enhance the controllability and increase the power transfer capability. So these FACT devices are used to improve the capability of the power system. Like sometimes we have problems with the voltage may increase or decrease. These FACT devices are used to improve the quality of the signal which are transmitted. Like sinusoidal waves is transmitted, sometimes it is disturbed, so the quality is also improved. It helps to remove the harmonics of the power system. Similarly, it is also used to improve the frequency fluctuation. Sometimes due to the increase in the fault, or due to the fault, or due to any sudden change in the system, the frequency is changed, so it is also used to maintain that fault. So these devices are the main component of it. So I already told you that there are the common types of power which are used is active power and reactive power, and the combination of active and reactive powers is the apparent power. So what is active power? Active power is the actual power or the true power which is being consumed by the load, and it is this power is due to the resistance in the power system. What is the reactive power? This power is due to the storage element or the capacitive or the inductive element which are present in the power transmission system. Similarly, this reactive power reduces the output of the system. So we need sometimes the output voltage is increased, and sometimes the output voltage is decreased. So we need to add the reactive power to improve to decrease the voltage level, or we need to add the reactive power to increase the voltage level. So these are used. Similarly, the apparent power is the combination of the active and the reactive power. So if we reduce the effect of the reactive power, then the overall power is almost equal to the active power, which is the main useful power which is required by the power system. So the advantages or the features which normally the FACT devices offer is it gives us fast voltage regulation. It increase the power transfer over long AC transmission line. Similarly, the damping of active power oscillation, it also removes that one. Similarly, we have load flow control in meshed system. It also improved line loadability. It improves the steady state stability of the power system. It improves the transient state stability of the power system. Similarly, it gave better load division on parallel circuits. It reduced voltage drop in the load areas. It reduced transmission losses. Or similarly, it has a better adjustment of the line loading. So these are the features which are offered by the FACT devices. So there are four different types of FACT devices which are commonly used. One is series connected controller. Second one is shunt connected controller. Third one is combined series controller, and fourth one is combined series shunt controller. So in order to understand these four controllers, we need to understand the basic series and parallel compensators which are used in power transmission. So the shunt compensator which are used in power transmissions are normally connected in shunt, and they will produce additional current in the power system, and that is transmitted to the load. The common type of shunt compensators are STATCOM and static var compensator, which are used in power transmission. Similarly, the combination of series compensator, which are normally connected in series with the transmission line, and they are commonly are thyristor control switched capacitors and fixed series capacitor techniques, which are usually used in series composition. They are also used to increase the voltage level of the transmission line when it is required. Similarly, for the series connected factor controller, it is basically a series compensator, but it it is basically a series compensator, but it used thyristor or power electronic devices to improve the efficiency or overall the disturbance of the uh, overall disturbance of the power system. So the commonly used series compensators, yeah, series factor controllers are SSC, SSC, TCSR, IPFC, SSC, and TCSC. So these abbreviation of these controllers or the description of these controllers I will discuss in detail in the next slides. So when the factor controller are connected in series, it is known as series controller, series connected factor controllers. And when the fact devices are connected in parallel, it is known as shunt connected factor controller. And the common type of a shunt connected factor controller are TCR, TSR, STATCOM, TCBR, and TCS. These are commonly used for the shunt connected. Similarly, when we use multiple series connected system, then it is called combined series fact controller. And when if we use one series and one parallel combination, then it is called series shunt connector. And among these four controllers, the commonly used controller is a series shunt controller. It is the commonly used controller, because in the series controller we have to design the shunt controller with which have a capability to control all the currents. As you know that in the series circuit, the main current will flow through the main through the circuit. So our capacitor, inductors, and the rectifier, thyristors are specially designed based on that current. But in the shunt series controller, we we use a series we use shunt controller as a main component, and we use as series component as the secondary component, and the main current is controlled by the shunt component. So the overall efficiency of the designing capability of the system capabilities of the system is improved, but the cost of the system is decreased. So the advantage of the fact devices is it can control it gives the capability for sustainable substantial increase in the availability and reliability of their line network. It improves both dynamic and transient stability of the system, and the quality of the power is also improved. So the common spec devices are static var compensator, similarly thyristor control rectifier reactor, thyristor switch reactor capacitors, thyristor connected reactor, that is known as TSR. Then we have then we have static series synchronous compensator, unified power flow controller, thyristor control series capacitor, thyristor switch series capacitor, thyristor control series reactor, thyristor switch series reactor, interline power flow control, and thyristor control phase shift transformers. So if you see that majority of the components are thyristor controlled, so we use thyristor as a power electronic device. And when we use reactor, then it is a combination of resistance capacitor and inductor. When we use simple capacitor, then it is a simple capacitor based system. Same. So this is the basic description of the fact devices. If you want to see the detail of the fact devices, it is explained it will be explained in the next lecture, hopefully. Hopefully you understand the main composition of the fact devices. Thank you. Stay blessed. Allah Hafiz.